In the previous section, we studied the wave nature of light. We found that wave features such as diffraction and interference only became large when the physical distance, such as slit width or thickness of a thin film, were of roughly the same size as light's wavelength. Most ordinary objects are much larger than the wavelength of visible light. When light travels around such large objects, its wave properties can generally be ignored. The study of light in this region is called geometric optics. In geometric optics, we describe light's propagation by a straight line with a designated direction. This line is called a ray, or a ray of light. A ray of light travels in a straight line until it interacts with some physical object. The simplest example is light interacting with a flat mirror, as illustrated. The ray coming in is called the incident ray. The ray going out is called the reflected ray. The incident and reflected rays lie in a plane that is perpendicular to the mirror. The ray's direction is described by the angle between the ray and the normal to the mirror. The normal to the mirror is a line that is perpendicular to the mirror. The angle of the incident ray is called the angle of incidence, and it is written as theta sub I. The angle of the reflected ray is called the angle of reflection, and is written as theta sub R. When reflecting off a mirror, the angle of reflection is equal to the angle of incidence. This is known as the law of reflection. Reflection which obeys this law is called specular reflection. Other surfaces are very rough at the microscopic level, and as a result, light reflects off at a variety of angles. This is known as diffuse reflection. Also, many surfaces will absorb some colors of light while reflecting others in a diffuse way. This results in the wide variety of colors we see in the world around us.